In this video, let us have a look on what is correlation and what is correlation coefficient. Let me explain what is correlation with the help of an example. In this table, we have cost of rice and the quantity sold. When the cost of rice is 35 rupees per kilogram, the quantity sold is 100 kilograms. The cost of the rice is 37 rupees per kilogram. The quantity sold is 95 kilograms. So we observe that as the cost of the rice is increasing, the quantity sold is decreasing. The same data can be represented through the graph. In this graph, we have x-axis represents cost of rice and the y-axis represents quantity sold. The same point can be represented through the graph, and this graph is called as scatter diagram. So in this scatter diagram, we observe that as the cost of the rice is increasing, the graph is decreasing. There's a declining trend in the graph. Hence, we say that there exists a negative correlation between cost of rice and the quantity sold. Let me take up another example. In this table, we have cost of onion and the quantity sold. So the same points can be represented through the graph, and then we observe that in this scatter diagram there is no decreasing trend and there is no declining trend. So hence we say that there exists no correlation between cost of onion and the quantity sold. Let me take another example. In this example, I have cost of watch and the quantity sold. And we observe that in this data, as the cost of the watch is increasing, the quantity sold is also increasing. The same data, when it is represented through the graph, we obtain a scatter plot like this. So we observe that as the cost of the watch is increasing, the quantity sold is also increasing. So hence there exists an upward trend in cost of watch and the quantity sold. Hence we can say that there exists a positive correlation between cost of watch and the quantity sold. So every time it is not possible to analyze the relationship between two variables through the help of a scatter diagram. Hence, Carl Pearson gave a mathematical formula to measure the correlation between the two variables, and this formula is called as Carl Pearson coefficient of correlation. So Carl Pearson coefficient of correlation is given by the formula R is equal to n into the number of observation. Here n represents the number of observation multiplied with total of x into y minus total of x multiplied with total of y whole divided by root of n into total of x square minus total of x whole square, which is multiplied with n into total of y square minus total of y whole square. So here, after calculating, if we get the R value as equal to 0, then we say that there exists no correlation between the two variables x and y. If R value is equal to 1, then we say that there is a perfect positive correlation between the variables x and y. If R value is minus 1, then we say that there exists a negative correlation between the variables x and y. And if the R value lies between 0.75 and 0.99, then we say that there is a strong positive correlation between the variables x and y. Let us take an example and find the correlation coefficient mathematically. Here we have got 5 persons A, B, C, D and E and their weight and the blood pressure. Let us represent the weight as X and the blood pressure as Y. And then let us sum up all this data. We get total of X as 874. Similarly, when we add all the Y data, we get total as equal to 734. So then you multiply x with y. So when we multiply 150 into 125, we get 18750. Similarly, when we multiply 169 with 130, we get 21970. So similarly, multiply all the data and sum all the data. So total of xy will be equal to 129140. Similarly, take the square of all the x data and then we call it as x square, and then again similarly sum it up, we get the total as equal to 154086. Similarly, take the y square, that is y into y, that means 125 into 125, we get 15625, and 130 into 130, when we multiply we get 16900. Similarly, multiply all the data and then square this data and then total will be getting as 109186. So now substitute all this data in the Pearson coefficient of correlation formula. So substituting here n is equal to 5 because we have taken totally 5 number of observation, 1, 2, 3, 4 and 5. So here n is equal to 5. So 5 into then total of xy you substitute minus total of x is 874. Similarly, the total of y is 734 divided by root of 5 times total of x square. So which is 154086 minus total of x whole square. So total of x we got it as 874. So substituting 874 square. So multiplied with n is the number of data under y we have taken. So total number of data we have taken is 5. So 5 into y square. So y square we have calculated as 109186. Substitute that minus total of y. Total of y is 734. So 734 square. So after calculating, we get the value of r as 0.6101. Even though the value of r is positive, it is not very close to 1 because we saw that the correlation coefficient r value lies between -1 and the +1. If r is very close to 1, then we say that there exists a perfect positive correlation between the two variables. But here, since the r value is 0.6101, we say that there exists a moderate correlation between weight and the blood pressure. Let me take another example. In this example, we have got price and the demand. So here let us represent the x as the price and let us take y as the demand. So similarly, so let us find out x into y, similarly x square and the y square, and then we shall add up total of all the values and then represent those values in the correlation coefficient formula and then calculate the total values and we get the answer as minus 0.96. So here R value is negative. That is why we say that there exists a negative correlation between price and the demand. That means we can observe here as the price is increasing, we can see that as the price is increasing, the demand is decreasing. So therefore, we say that there exists a negative correlation between the price and the demand represented in this data. This is how we can calculate the Pearson coefficient of correlation.